Lesson 8.4 really covers the second major topic of Chapter 8, and that is logarithms. This is something new for Algebra 2, and really we're going to use our calculators to help us learn what logarithms are. We're going to do a little exploration here. And if you look at a graphing calculator like I have up here on the screen, right next to the 7 button, just to the left of it, is a log button. Also right next to the 4 is an ln button. We'll call that the natural log button, but we'll get to that soon enough. Quick exploration, let's figure out what the log of 10 is. Real quickly, we could see it's a 1. Log of 100, well, we can see that's actually a 2. Log of 1,000, well, very quickly we can see that's a 3. Log of 1, we'd get 0. And finally, in this little exercise off to the side, log of 1/10, we get -1. Now, real quickly, just coming back here, writing down these numbers that we just saw. Very often, kids might first assume that we're counting the number of zeros that we have typed into the log. But from our last example, you can't have a negative number of something. Here's something to help us. Every log has a base. There's a subscript, a number that's written down below the log, and there's an understood 10. Let's take a look just at our second example where we had log base 10 of 100 equals 2. Without too much time, hopefully students will be able to see a relationship between the 10, the 2, and the 100, namely that 10 to the second power is equal to 100. Look up here, we'd have 10 to the 1 power would equal 10. Look at this third example, 10 to the third power equals 1,000. Look at this, 10 to the 0 power. Any non-zero number raised to the 0 power is 1. And super important, our relationship with negative exponents, something we can't forget. 10 to a -1 power, well, that's the reciprocal. It's 1 over 10. So it says, this would lead us to believe that logarithms are exponents. Logarithms are exponents. Look, what the logarithms here are equal to are the numbers 1, 2, 3, 0, -1. But look at these numbers, 1, 2, 3, 0, -1. They are exponents. These exponents were equal to logs, so we could think of logarithms as being exponents. Well, and this is a little saying that will help us quite a bit. The base of the logarithm, which is that subscript, you see the 10 written in each of these, is the base of the exponent. Always. And where we're going next is actually the definition of a logarithm. We're going to write this very abstractly, but my goodness, this is what we really need to know. I'm going to put some stars right out here. This is new to us. This is something that we didn't learn in Algebra 1 or in geometry. But look at this. Log base A of B equals C. Look down here. I'll go A to the C power equals B. A to the C power equals B. As some teachers in our school will explain this, it's like you make your log circle. You have your logarithm on the left equal to a number on the right. Go down to that base. That base of the log is also the base of the exponent. A is raised to a power. The power is never inside the log. The power is set equal to the log. So we make that little circle there, and we find that a logarithm can be rewritten as an exponential equation. Well, some of these problems are going to be ridiculously short. Look, it says change each logarithmic equation to an exponential equation. Well, you know what? Let's make a log circle. We could say 5 to the third power equals 125. We are done. Look at number 2, far more abstract, but we'll say p to the r power is equal to q. We can also work in reverse. Now, sadly, we're not going to be able to do a log circle the way we just did before. We don't even see a log written out. But we can say the base of the logarithm is also the base of the exponent. Look, we have 4 is our base. The exponent, the power, is actually a 3. So I'll put 4 down here. Remember, the power is equal to the log. Never ever put the exponent inside of the logarithm. The exponent, the power, is set equal to it. The last number that we have in this relationship is 64. Now we can check if we're right by making a log circle, and you can see that we are. 4 to the third is equal to 64. Take a look at example 4 here. Same issue. The base of the log is the base of the exponent. We would have to have 9 written as our base. The power is 1/2. We always write our power outside, set equal to the log. The last number that we see is a 3. You might wonder, wow, is this correct? Well, draw yourself a log circle. 9 to the 1/2 is equal to 3. Okay, the number e is a new number that we're looking at, a very important number in mathematics. E is about 2.71828. We could bring our calculator up very quickly, and if you look at this LN button right next to the 4, just above it is the e to the x button. We could hit second ln and get e raised to a power. How about we just type in e to the first? You could see it's about 2.7. Well, that being said, if we saw a log base e, remember logs can have all different types of bases. We're going to be talking about how those bases must be positive numbers, but e is a positive number. Log base e is written as ln of x. Hey, there's our ln button right next to the 4. And we read that as, it is read as the natural log of x. The natural log of x. There are 2 logarithm buttons on your calculator. One's the common log, log base 10. The natural log is really log base e. Okay, for our next set of problems, take 5, number 6, number 7, set them all equal to x. And what we'd like to do is find out what this x is. It says evaluate. Well, we've got the natural log. Remember, natural log is just like the common log in that a base is understood. We never write that base officially out. We can, at this point, to help us, we can make a log circle. Look at this. E to the x would equal the inside of that log, e to the 7th. Hey, what would x equal, do you think? Well, look at this. X would, of course, very simply have to be 7. Look over here at number 6. 7 raised to the x is equal to 49. Make that log circle. You would be asked then, what power would this have to be? 7 to what power is 49? Well, hopefully without too much work, you eventually would get 2. Number 7, 2 raised to the x power is equal to 16. Here you just have to find out what power I have to raise 2 to get 16. Well, 2 to the third is 8. 2 to the fourth, though, if x is equal to 4, this would be true. Alright, well, let's take a look at number 8. Our x now is inside our logs, but again, how are we doing so many of these problems? log circle. Base of the log is the base of the exponent. 5 to the second power is equal to x. Nice and simple. You get x is 25. Look at number 9. 3 to the negative 2 is equal to x. Hey, very important review for negative exponents. That's 1 over 3 to the second. And 3 to the second, of course, is 9. That's 1/9. Real quickly, let's go to the back. We could use a calculator here, but for number 10, it just says log. There is a base 10. For number 11, it just says ln, or natural log. That has an understood base of e. And likewise for number 12, we have a base of 10. We're asked to go to the nearest thousandth using a calculator if needed. For number 10, we don't really need a calculator for this one. Do a log circle. 10 to the 5th is equal to x. I hope you know that 10 to a power would have, the power tells you how many zeros you have. We'd need 5 zeros, a 1 with then 5 zeros following it. You could quickly double check that 10 raised to the 5th is 100,000. Okay, let's take a look here. This would be e to the 2.1 is equal to x. Well, where do we get e again? Second natural log. That's the button right next to the 4. And then we type in 2.1. And you'd get about 8.166. 8.166. Finally, we'll go 10 to the negative 2.3 would equal x. So very quickly we'll just type that in. 10 caret negative 2.3. Looks like we'll get 0.005. So that's all we're doing today. Remember your log circle, and hopefully you're doing all right.